Okay, so let's try solving the second problem that we have here for our given figure for sectors of circles and also the sectors of different polygons. So we have here Lynn plans to create her own signature plate made of materials found in their community, as shown on triangle TAS, with TR being one of the equilateral triangle's altitude on the plate. If the area of the shaded region over here is equal to quantity 3 times square root of 3 minus pi squared cm squared centimeters. So what is the length of one side of the triangular plate? Okay, so how can we find the measurement of the sides of TS? Okay, how can we find the measurement of that one? TA and then SA for this problem. The side measurements, okay, for this problem, we can find the side measurements TS, TA, and SA using a very cool trick that we're gonna use here. So since this is an equilateral triangle, therefore it's equiangular. All of its sides are congruent, therefore all of its angles are congruent. So therefore this must be 60 degrees, 60 degrees, and 60 degrees. So this is 60, this is 60, and this is 60 as well. Okay, so therefore if this is the height and this acts like the perpendicular bisector of the circle, so therefore that part must be 30 degrees. So this must be 30 degrees for this one. And we can draw another line segment here, okay, that's going to bisect, okay, that's going to be again one of the altitudes of the triangle since it's an equilateral triangle, and therefore we can create here a 90-degree angle. Okay, this is a 30-degree angle, and this is going to be a 60-degree angle. So therefore we have here a right triangle, and not just an ordinary right triangle, we have a special right triangle. That's a 30, 60, 90 triangle. And to get the area of the entire right triangle, so for this one, we can create an equation. Okay, so for this one, this is going to be the area, okay, the area of triangle, okay, the area of triangle, let's say we can name this as point C, and we can name this as point D. So we can say that the area of triangle TCD, okay, TCD is going to be equal, okay, the sum of the sectors of sector ODC, okay, sector ODC plus the measurement of the area given in our problem, okay, the area of the shaded region, the area of the shaded region, and more specifically, we can get the area of the shaded region. Okay, so the area of the shaded region is just gonna be equal to the area of triangle TCD minus the area of the sector. So the area of the sector ODC on this problem. And since we know that the area of the shaded region here, it's equal to 3 square root of 3 minus pi. Okay, we can say that to get the area of triangle TCD, we can use base times height divided by 2. Since we know that the base is gonna be r, or the radius of the circle, okay, for this one. And we also know that the value of TC, okay, the value of TC for this one, height here, since it's opposite of 60 degrees, we can say that the height is equal to x squared of 3, where x is the smallest side measurement, and therefore the height should be equal to r squared of 3 for this one. Okay, so this is gonna be base, which is r. Okay, so that's gonna be r times r squared of 3, the height, all over 2, minus the area of the times theta for this one. So this is gonna be the area for our given sector. Okay, so if the radius, so that's gonna be 1/2 r times theta. So therefore this is gonna be 3 squared of 3 minus pi is equal to r squared of 3 all over 2 minus, okay, so that's gonna be 1/2, okay, 1/2 the radius times theta. And theta over here, that's measured in radians. Okay, so to get the measurement of the degrees here in radians, since this is the sector that we're talking about on this one, so that's sector OCD, and we have here 60 degrees. So therefore, the radians value of 60 degrees is just gonna be pi all over 180 times 60 degrees. So that should give us one third pi, or just simply pi all over 3. Okay, so therefore our formula is complete. So let's try to simplify it. So this is gonna give us 3 square root of 3 minus pi is equal to 1/2, okay, r squared square root of 3, okay, times 1/3, okay, for this one. In our radians value here should have a squared. Okay, so the formula for finding the area of a sector, okay, should be r squared theta. Okay, so therefore this should be r squared, and this should be squared as well. Okay, for this one. Okay, so to write it cleanly, so this is going to be 3 square root of 3 minus 11 is equal to 1/2 r squared of 3 minus 1/2 r squared, what's the value of our theta in region? So that's pi all over 3. Okay, therefore for this problem, we can factor out 1/2 r squared. So that should give us 1/2 r squared multiplied by square root of 3 minus pi all over 3 for this one. And what we can see, guys, okay, for this one, if we minus square root of 3 minus pi all over 3, so what's square root of 3 minus pi all over 3? So that should give you 3 all over 3 square root of 3 minus pi. Okay, so therefore 3, okay, so 3 square root of 3 minus pi is equal to 1/2 r squared multiplied to 3 square root of 3 minus pi all over 3. So therefore, we can cancel out the numerators for this one by multiplying both sides by the reciprocal of 3 square root of 3 minus pi, which is 1 all over 3 times square root of 3 minus pi. Okay, so therefore this cancels out, and what's 3 square root of 3 minus pi divided by 3 square root of 3 minus pi? That's just equal to 1. So 1 is equal to 1/2 r squared times 1/3. And what's 1/2 times 1/3? So that should give you r squared all over 6. And if we cross multiply this, therefore the value of r squared is just equal to 6, and therefore r, the radius of the circle, is just going to be equal to, so what's the square root of 6? So that should give you, there you go. So that should be the value uh, of our radius. Okay, so therefore the radius is equal to square root of 6. Okay, so if the radius is equal to square root of 6 for this one, okay, so there you go. So if the radius is equal to square root of 6, we can find the measurement of TC. Okay, so since TC is equal to x squared of 3, and we know that the value of the radius, which is equal to x, okay, so the x is equal to the radius, so that's gonna be square root of 6 times square root of 3, and that should give us square root of 18. And what's the square root of 18? So that should give you 3 square root of 2, right? There you go. So therefore TC is equal to 3 square root of 2. And since TC was bisected, it's been bisected by this perpendicular bisector over here, or the other height of the equilateral triangle. So therefore this is 3 square root of 2, and therefore CS must also be 3 square root of 2. So therefore TS, okay, TS is just equal to 3 square root of 2 times 2, which is equal to 6 square root of 2. So therefore, that's the side measurement of the triangle. That's going to be the side measurement for all of the sides of the triangle. So therefore, TS measures 6 square root of 2 centimeters. The measurement of SA is also 6 square root of 2 centimeters. And the measurement of TA is also equal to 6 square root of 2 centimeters. And we managed to solve it by using the area of a sector formula and also using our knowledge about area of triangles, specifically area of right triangles for this one. And also, there you go, the formula for the area of the sector really came in handy for this one. And also by using factoring, we managed to solve for the radius. The radius is just equal to the square root of 6, and it turns out to be the smallest side on the right triangle for this one. And that's how we solve this problem.